Okay, let's take a look here at sections 2.5 and 2.6. So 2.5, we're looking at measures of central tendency. And when we are talking about measures of central tendency, we are talking about the mean, the median, and the mode. The median is going to be the observation that marks the middle of a ranked data set. And this can also be the 50th percentile, or as we looked at previously, quartile 2. The mode is going to be the observation with the greatest frequency. So how many times a data value appears, the one that appears the most, that is going to be the mode. It is possible to have no mode or multiple modes. The mean, commonly referred to as the average, is the sum of all of our values and divided by the number of values. So we have same calculations for sample and population here, but we are going to want to start differentiating them. So when we look at our data, we have grouped and ungrouped data, and then we have a sample and a population. So just some symbolism here for your sample. So a sample mean is symbolized by an X with a line over it, which we call X bar. X bar here when we are talking about a sample mean. And that is going to be given by taking the sum, so sigma for sum, of our X values divided by N, where N is going to be our sample size. So I'm just going to do a little key over here. That is sum, and then N is going to be sample size. Okay, and X bar is your mean. Then a population mean is notated by the Greek letter mu. That looks like this. It's like a U with a front tail. And this is the Greek letter mu, so it's MU. And that's going to be actually the same formula. So sum of X, just when we're dealing with a population, we're going to use a capital N. So we say that's the population size. Okay, so about the sample and the population, sample is going to use the English alphabet. We'll write that up here. And a population is going to be using a Greek alphabet when you're looking at the notations. Okay, so you have the mu here for your population mean. Now, when your data is grouped, you are, okay, when we're grouping, remember we had that example where we were looking at ranges of test scores. So you're going to need to find a midpoint of your data. So we're going to introduce M for midpoint. And that's just going to be the middle of the groupings. So for a sample mean, that's going to be X bar equals the sum of your midpoint. Oops, let me go back here. Didn't mean to go back that far. Hold on a second. Nope. Okay, so we're back here. All right, so we have X bar is going to be the sum of your midpoint times your X values over your sample size. And then for a population mean, same thing. So you have a mu is going to be the sum of your midpoint times your X values over your population size. Okay, so those are your formulas. And it's really just doing the same thing that we've done previously where we found the mean, the median, and the mode. You're adding the values, dividing by how many. You're just looking at them now as formulas with different symbolism. So if we look at this next example, you have the number of books checked out from the library from 25. So there's a total of 25 IRSC students are as follows. So first of all, let's ask ourselves, is this a population or a sample? And when I'm looking at this, number of books checked out from 25 IRSC students, so it looks like this is just a sample. Okay, so we're just dealing with a sample here, and we want to find the mean, the median, and the mode. So we're going to start with the mean. So the mean would be X bar equals the sum of our X values divided by how many. Okay, so we're going to go ahead and do that. So let's see here. We're going to add all of these values together. So I'm going to go ahead and grab a calculator, pull it in here. We're going to add these in. All right, so we've got 0 plus 0 plus 0 plus 1, 2, plus 3, plus, oh, we have another 3 there. 3 plus 4, plus 4, plus 5, plus 5, plus 7, 7, 7, 7, plus 8, plus 8, plus 8, plus 9, plus 10, plus 10, plus 11, 11, 12, and 12. All right, so that gives us 154. So the sum of x is going to be 154. And we had our sample size was 25. So let's go ahead and do that. 154 divided by 25. And that gives us 6.16. Okay, so our mean is going to be 6.16. Now you can also do this in the list function in your calculator, but usually it is just faster to do it adding together like we just have. The median, there's going to be 25 pieces. So if I'm going to find the median, I want to take 25 and divide it by 2, which is 12.5. Okay, so let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. And then we're going to go from the back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's that middle value, 7. That's our median. And then the mode. We've got a couple of repeating ones. We've got 3 goes twice, 4 twice, 5 twice, 7 4 times, 8 3 times. And yeah, so it looks like 7 is the mode there because that repeats 4 times more than any of the other numbers. Okay, now that is with ungrouped data. So I'm going to go ahead and pull an example with group data from your homework. Okay, so we're looking at this example here. The following table is a frequency distribution for the amount of hours worked per week by 100 IRSC students, and we want to find the mean for this data. Okay, so this is grouped data because you have this grouping here, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. So our formula for grouped data is going to be, well, actually, first of all, is this a population or a sample? So we'll ask this. So this is grouped, and this is a sample. Okay, so it's group data, and it is a sample. All right, so we are going to use the formula x bar equals the sum of m times x over n. Okay, so our x is going to be our frequencies. What we want to do here is we want to find the midpoints. So the midpoints are going to be the middle values of these. So I would just make another column here, call it m, and then we have our midpoints. So the midpoint of 0 and 10 is 15. And if you can't do it easily, you can always put it in your calculator here. So 15, I don't know if we make it small enough writing here. Yeah, not really that small, so I'm just going to make a new chart. All right, so midpoints, we've got 5. Midpoint of 0 and 10 is 5. Midpoint of 10 and 20 is 15. 20 and 30, 25. 30 and 40, 35. And 40 and 50 is 45. And then our x value is our frequencies. So we had 26, 21, 25, 22, and 6. So now we want to multiply them. So we're going to do midpoint times the frequency. So we're just multiplying these columns. So we're going to go 5 times 26. That's going to give us 130. 15 times 21. 315. 25 times 25. 625. Next we have 35 times 22, 770. And then 45 times 6, 270. Okay, so you have your midpoint times your frequency, and then you want the sum of those. So we're going to add that column together. So we've got 130 plus 315 plus 625 plus 770 plus 270. That's going to give us 2,110. So our sum of mx is 2,110. And then our sample size, 100 IRSC students. So 2,110 divided by 100 gives us 21.1. Okay, now you can do this in your calculator when we do standard deviation and variance. I will go over that, but for right now, I'm gonna leave it just like that. All right, let's go on to 2.6. Let me go back to where we were. Okay, so 2.6, we're talking about our distributions. So skewness, mean, median, and mode. So it's different types of distributions. You have a uniform distribution. All classes have the same frequency or relative frequency. So all bars are going to be the same height. So if we look down to this example here, that is a uniform distribution. All of the bars are the same height. A symmetric distribution, look over to the left here, there exists a vertical line such as the left and right halves. So if I split this in half, they are mirror images of each other. With symmetric distribution, we assume that the mean and the median are equal. Okay, another thing that we call this for symmetric distribution is also called, which we're going to see a lot once we get to chapter 6, normal distribution. Actually, we're going to do a little bit of it with this chapter too. Then we have our skewed distribution. So if you look down a little bit, you can see the skewed. So a skewed left distribution, the longer tail. So you're looking at the tails for the distribution, not not the humps. Okay, so you're looking at the tails. Less data are on the left side of the distribution. And then for the skewed right, less data is on the right side. So if you look at these examples here, the tail of this data, if I draw a curve, goes to the right. Okay, so this is our skewed right distribution. If I look at this one, I've got a majority of data here. The tail, the smaller part of the distribution, is left. So when we look at the distributions for skewing left and right, you're looking at the tail where the smaller part of the data is. Okay, so this is your tail here. And that is actually it for 2.6. So there's really not a lot in 2.5 and 2.6. We will look at our next video for 2.7 and 2.8.